Thank you. Hi, everybody. I was asking myself the same question about how can you follow such an act. I'm going to try to do that by apparently attempting, I thought succeeding, but apparently attempting to hack a serverless application. So I think we're good and we're up there. So I think Ant kind of presented me a little bit. I've got a rich security background, and today I deal a lot with open source security, and also have been digging into serverless security and PaaS security a little bit as well for the last year or so, and have done some writings about it. And some of you may have been to either that meetup or to Serverless Conf and have seen me give a kind of a more theory talk, if you will, on serverless that talks about serverless security conceptually, which issues are addressed, which issues are not. I'll share these very few slides here, and you can go back and find a video and slides of that talk. This talk is not that. Instead, what we'll do is the opposite. In fact, we're going to spend pretty much no time in slides. And what we're going to do is we're going to take a sample serverless application, which I think is typical, like, I think a reasonably simple and reasonable serverless application, show some vulnerabilities in it, and hack in, do some multi-step hacking, which I don't know how much of exposure you've had. There's some fun aspects to it as well. Security at the end of the day is risk reduction, which makes it boring if you think about it this way. It's like this insurance, and hacking is fun. So the only way to really try and pass some of these messages along is to do it this way. And in the process, we'll talk about these security flaws, talk about how can you, of course, avoid having these problems in your own applications, and then kind of come back and summarize. Which I guess is in my agenda slide. I didn't remember that. So, out of the slides. So in today's application, I'm going to use AWS Lambda, because it's sort of the de facto serverless framework. I will use the serverless framework to deploy an application. I've actually already deployed it, but this is the sort of the setup that I have for it. I'm not going to do a primer on both of those, so I'm assuming a certain amount of basic knowledge, but hopefully the concepts are the same even if you don't follow the syntax. And then, of course, we'll sort of dig in. So let's start by introducing our serverless application. We'll start with the API, because many of the serverless systems are like that. This is, of course, a to-do app, which is maybe like JavaScript roots a little bit, and I think JavaScript has to be to-do MVC. So this is at least the to-do, if not the MVC part of it. So it's one of the serverless examples, the serverless framework's examples for using DynamoDB. So at the top of the serverless framework kind of manifest here, you will see some details we're not going to dig into that just give us access to DynamoDB. And here we have some simple sort of CRUD actions here. You can create a to-do list. You can list the to-do items that you have. You can get additional ones. You can update an existing one, delete. So it's just sort of simple actions for it. So let's do that a little bit. I'm going to zoom in a little bit here. I hope this is enough. And I just sort of have a bit of a cheat sheet for myself, so I don't need to type it every time. So I've already deployed this, and this application sits right now in serverless goof host. And just to be kind of extra clear, this is running with my wife's Amazon account, so no vulnerable network access to the Snyk network. I'm not sure she knows this, but hopefully that's not going to be a problem. So we're going to start off by just trying to sort of invoke this application a little bit. We're going to do a curl to get the to-dos that we have there. We have none, so let's try and add some. So we can do a little post action here to just sort of post to this host and say, call mom, something I definitely need to remind myself to do more often. And then if I go off and I request this to-dos list, I'm going to see that item in there. Is the font big enough, or I think I'm starting to sort of test my sort of line length borders here. Let's add a couple more items. So you might have learn serverless, and it may be that this is Friday and you might only want to learn serverless after the weekend. So we actually have a little bit of a extra feature here, which you can say, well, learn serverless in 3 days, or within 3 days. And what that would do is it would calculate a little bit the time period that I just talked about in 3 days, and would put some understanding in milliseconds of how much it is. So this is sort of our application. Again, we can kind of go off and list the items that we have. And maybe one little addition that I had here is that there's actually also the ability to render this in HTML. Of course, HTML is not really meant for the terminal. So if I just go in here and open this up, I will get my very fancy to-do rendering. CSS is not my skill set. This is a mobile first application. So this is the mobile view. And if I say device equals desktop here at the top, then I will get the desktop view. Which looks very, very, very different. Which it's important for it. So I didn't have time to sort of fully refine the narrative. I tried to sort of focus on the security. So this is our application, goof to do, everyone goof to do. So now let's start sort of talking a little bit about this application. So it's a simple enough application. We could kind of go off in here and see a bunch of the files, but really it's fairly straightforward. And when we talk about the security risks in it, the first step that we ask is about vulnerabilities. So, okay, this is an application, it's deployed, it has vulnerabilities. We're not going to attempt, and in fact, like we're in really good shape in terms of Lambda's security itself. So we're thinking about vulnerabilities in our system, and I'm going to start with the area that's kind of close to what I do for a living as well, which is looking at vulnerable libraries our application might have. Now, because this is function as a service, you're not managing the servers that are underneath. So you don't need to worry about a vulnerable OpenSSL library or a vulnerable bash or any of these sort of heartbleed, shell shock, logjam kind of designer vulnerabilities that make the rounds. But you do need to worry about vulnerabilities that are embedded into your application, such as struts Java framework that might have a remote command execution, or a denial of service vulnerability in a RDOS vulnerability in a JavaScript object. So we're going to do that here with Snyk. We're going to uncover a couple of vulnerabilities, and then we'll show them in action and what they mean, and then we'll go further. So I'm going to use Snyk for this. This is, again, kind of my service. You can use this as part of a development process. You can use other tools here as well. So just sort of choosing this as an example. And I'm going to add project here, connect to Lambda, where I already gave it the sort of API credentials to connect. And it will list all of the different Lambda functions that I have in here. I'm just lazy here. I'm going to check them all and say add them to Snyk. And what's going to happen now is that Snyk is going to go off, download the zip file from each one of these Lambdas, and expand it out and see which libraries are you using inside of each, right? Like which dependencies are you using, and then track that up against the vulnerability database and see whether any of them are vulnerable. So while this is going, I think this is already done. So we're going to go to the project, and I have a bunch of applications here, not just the ones that I mentioned. So let's look, for instance, at the create report here. So I get this sort of detailed report that talks about this specific vulnerability, and there's a report that tells me there are 3 high severity, 3 medium severity, and 1 low severity vulnerability here. I'm not going to dig through all of them, so it means I'm using some libraries that have vulnerabilities. For starters, let's start with a simple one. I'm going to look at RDOS. So who here knows what a RDOS vulnerability is? Yeah, not that many. So denial of service vulnerability, who here knows what a denial of service vulnerability is? Yeah, so denial of service takes you kind of offline. A regular expression denial of service is just a specific variant of it in which a regular expression, which is really an algorithm, takes a non-linear amount of time to run, and by doing so, it kind of takes out your process. So RDOS is a very interesting entity in the world of Lambda. So let's sort of dig into that a little bit. So what we can see here is that we're using this MS component, and it has a regular expression denial of service vulnerability. We use MS, so I'm going to spare you some discovery here. We use MS as part of our calculation there. When I said, learn serverless in 3 days, I could have also said, 2 months, and it would calculate, how much that means. Or I might not have months, let's say, 10 minutes. And it would figure out, what that time is in milliseconds, so it can remind me, X milliseconds after how much that is. So we use MS to parse that component. So we're going to play around with this a little bit. We know that MS uses regular expressions, and it has a RDOS vulnerability in it. So what might I try? A very long string, good proposal. So the whole thing about a regular expression is regular expressions are state machines. And when you talk about sort of a sequence of actions on them, then they might take, again, a non-linear amount of time to process compared to the length of the input. Once again, I cheat a little bit here. I've got bit of a script here that can do this. So what I'm going to do is I'm going to run a command that would put 65s in here. So I'm going to, learn serverless in whatever it is, the 5555 60 times to run it. And I will run this, and it completes. Doesn't seem too problematic, but this was just 60 characters. So I can go on here, right? I can go and I can say, maybe I'll do 600, maybe I'll do 60,000, right? Still completes fairly quickly, no problem really observed. The thing about a state machine is that the problem is when you need to exhaust all the possible states. Or in other words, when you match the regular expression, you're in better shape than when you don't match the regular expression. So I'm going to do a little bit of a trick here. In fact, I'm going to do 3 of them. And I will change this S to an A. So I'm going to say minutes to minutia, or minuta, which in turn means it's almost matching the string, but not quite, which would force the regular expression to do what's called catastrophic backtracking, very appropriately named, and go back and calculate things again and again. So if I run this on 60, no problem. If I run this on 600, still pretty good. If I run this on, I'll do 6,000, and then if I run this on 60,000, it's stuck. Now, because this is serverless, something interesting is happening. First of all, within 6 seconds, Lambda times out. This may be configurable, I'm not sure. But unlike a regular denial of service vulnerability, this did not actually deny service to your clients. If you ran this now, right, if somebody else was making a request at the meantime, then the service would still be available. Lambda would spin up another instance of this function and would serve the individual. So your service is still online, and that's awesome, and that's one of the core capabilities that functions gives you, that sort of function as a service gives you. Now, when you look at the bill at the end of the month, however, you may be a little bit less happy with those results. If I look a little bit, we're going to just sort of look a little bit behind the scenes here, zoom in. Oh, I don't know how well the AWS UI would work with zooming, sorry. Let's find my create function here and my log. I'll do something different. I'll do this instead. Does this work? So what you can see here is that my very last run took 6,000 seconds, right? Build duration is 6,000 milliseconds. And the previous ones with 6,000 took 330 milliseconds. So a very sort of disproportionate amount of time. And then the previous one took 30 milliseconds. So basically, somebody can't take you down with a redos, but they can make you pay, quite literally. Okay, just getting warmed up, right? So this is one aspect of serverless security. All in all, a positive, but not something you can ignore entirely, because this problem is addressed. So far, so good? Cool. The next one we're going to look at is a little bit more severe. So we're going to come back here, and we're going to look actually at the one that was placed at the very top of the screen, which is code injection in the Dust.js LinkedIn templating library. Who here has heard of Dust.js? Okay, a handful of people, not many. It's LinkedIn's templating library, like EJS, like Handlebars, and it's also used at PayPal and a bunch of others. And it has a remote command execution. Let's take a look at it a little bit. So what we do for, how do we use Dust.js? So first of all, we use Dust.js to render our to-do list, right? So this is my amazing HTML with its amazing CSS. Basically, what it does is it repeats when I choose to render the items, it goes off and it repeats the to-dos items and puts a little bit of a div item in for each of them. It also has, of course, we had to make this mobile friendly, so it has a bit of a condition in there. This condition is kind of the core of our problem. So underneath this condition, we find out that the device, the cond evaluation that happens here, which is very kind of nice and elegant, you can just put a bit of a JavaScript condition here, is evaluating using eval. And eval is an evil function. It's generally a very insecure, it's very, very hard to secure eval. And yet it's used, it's super convenient. It's sort of a classic convenience versus security type of trade-off that happens all the time. And as a result, there are some scenarios in which this component, if you can control the input parameters, say device, you might be able to play with this a little bit. So let's play a little bit. So first of all, let's say you know this, right? You've kind of explored and you found out some of this internal information around the use of device. What would be the first thing you try? Any thoughts? Okay, yeah, this might, sorry? Yeah, precisely. So if you know, whenever you want to escape a sandbox, whenever you want to escape quotes, then you do something like this. You do a device equals desktop, and you add a single quote, or something like that. I'm going to do %27. Right? And if you do this, nothing really bad happens here. You just get the response back as it did before. And the reason for that, not to sort of belabor this, so I focus on serverless and not this specific vulnerability, is that Dust.js is LinkedIn is a serious company, and they've worked this out, and Dust.js has some good security sanitization in there. So they're going to look for these single quotes and escape quotes and all these, and they're going to sanitize them. However, it turns out it was susceptible to something called type manipulation. So it only does this sanitizations on strings that come in. Node has this funky option, or in fact it's not Node, but one of the primary query string parsers in Node is called QS, and QS has this feature where you can do this, and what result is, this device close and open square brackets makes this element an array. You can do it in a bunch of other ways. So what that means is when I run this component, when I just run the same parameter but with an array, the entity that goes into the template is actually an array, and that array is not properly sanitized. So if I run it like this, there is no problem. I just get the response back. But if I run it with a %27, some error occurred. Because now this wasn't sanitized and made it all the way, and suddenly I have the single quote, and I evaluated a bad exception, and the whole thing blew up. So this is sort of our entry point into it. We're not going to sort of dig through all the steps, but let's just sort of see bottom line. If you were to explore this, what can you do? And we'll do a couple of things, and we'll use this to expose all the weaknesses. So the first thing we're going to do is we're just going to prove it to ourselves with our internal insight that this indeed succeeded. So what we will do is we'll say, hey, desktop, close the quote, minus, because this is just an evaluation, console.log, jeffconf was here, into the AWS log. Not a very wise attacker thing to do. Like, all he does is leave a footprint. But let's try it anyway. So we get the response back because there was no error, and we go back to our AWS console, and if I manage to sort of zoom in sufficiently, where is this? This is the render function, and we get in, scroll down, and you can see that jeffconf was here. Now, that's not very helpful, like if your attacker has access to your AWS log console, you've got bigger problems. So what would an attacker actually do? So they would start sniffing information from it and send that information out. So to do that, we need a destination for that attacker to send it to. As it so happens, I have one over here. My SSH died. Hold on. Oh, did I? 72932. There we go. Okay, so I've kind of pre-prepared just a little non-serverless, a serverful instance here, and I'm just going to listen to incoming requests, and then I will send this slightly bigger payload, which, if you follow, requires child process over here, and then execs a curl that goes off and sends the etc passwd file. And if I do this, et voila, we got our etc passwd file, which is very interesting, by the way. I kind of was tempted to start learning, like, these different users, and you can see it has FTP on it and mail. Some interesting learnings about the sort of AWS Lambda execution environment. So, okay, not great, and this is maybe the second demonstration that I would have, which I would then now use to show other flaws in it. But so far, we've seen that libraries could kind of make you vulnerable, and we demonstrated the impact of a RDOS, and we showed a remote command execution, and now we're on this system. Not great so far, but let's talk a little bit about other things that we can do. So typically, attacks don't stop at one tier. There's really very rarely a mythical single request that comes down and downloads your database. Typically, these things happen in stages. So now I can run on your system on this application, and I want to do the next thing. So with that, let's talk a little bit about another pseudo-myth in the world of serverless, and that is that it's serverless. There is, in fact, a server behind. Now, you might say, fine, it's not serverless, there's a server, but it comes and goes. But you'd be wrong. In Lambda and in a variety of other systems, there is the notion of keeping a server warm, and it's necessary for performance purposes. So a system can actually run and operate, or sort of the same server would process multiple requests, and multiple requests from different users. So what that means is that if a service was compromised, if I got this remote command execution now and I compromise the server, then I can now compromise and modify the next application, the next user, or I can steal information that might have been left over from the previous one. To demonstrate this, I, for really absolutely no good reason, store my, it even says for no good reason, store the to-do items in my application to a TMP file. And the reason I use TMP is because the /TMP folder is not, at least not by default, I'm not aware of a way to change that, cleared between executions. So we have remote command execution. What can we do? No? I have some training to do here in terms of hacking. We can look at that TMP file. So we can do the same curl command that we've done before, but instead of just sending the etc path WD, we would execute ls-l on the /TMP folder, and we look what's in there. And what's interesting is, oh, sorry. My bad, I mixed my, the ordering here a little bit. So this is the one that actually does the ls-l for the dot. And what we can see here is we can see a lot of these goof to-dos renders that were created with a random file name every time. So this is just a demonstration of the fact that the servers are not stateless. They're not fully immutable. They are mostly immutable. They are immutable in the sense that you don't redeploy to the same server new code. But the service does exist and does service multiple different clients, especially when it's under load. A side note is that this, as far as I can tell, is limited to the same function. So everything you see here is this render. Now my create function also writes needlessly to the /TMP folder, but I don't see any of those TMP files here. So I only see the same function, and if I waited a while, the service would go away, and if I run it again, I'm going to get an empty /TMP folder. So it's an interesting experiment and might be worth exploring in your applications if you're leaving any sensitive data behind, because it just means that if somebody was able to come in, they would be able to penetrate further, or sort of to get access to more information. So far, so good. What else can we do if we have remote command execution on the service? So I can replace index.js. So I can definitely entirely replace the application. I don't have a good example of it, although I thought about it, just ran out of time. So because you're on this file, you can go off and you can actually modify the application. So future requests that go into that same function can do it. I didn't quite have time to set that up, but what it can do is you can at least look at these files. So for instance, and this is the command I had before, what this command does is an ls not on the /TMP, but rather on dot. So it basically tries to see which files are in my current system. So let's scroll back down over here, run this, and then when we see it over here, we can see this is the folder of our application. So you can see the exploit folder, which I just packaged in, node modules, package.json, readme, to-dos. And you'd also notice this admin folder. And this admin folder is because of a set of functions I've not yet introduced to you, but in my application here, in my serverless YAML, further down, I also have a couple of actions for administering this wonderful to-do app. I can back up the database, I can restore the database, and I've got a little API that tests that the credentials are valid before allowing users to do it. So let's take a look a little bit at this folder. And again, I have another sort of prepared action for it. And if I look at this folder, I can see that inside this folder, there is an admin folder, and then let's say I've already done the ls, I can just say /admin, and I just cat all the files in that folder. So it's interesting, it's an interesting folder. Let's see what we got. So we have a series of files here from administration. You can probably guess that that's already not very good. And then the other thing that I noted here is this. So this is my secret for this administration API. It's a really hard to guess secret. It's a UUID. It's really not something that somebody can just sort of enumerate away. But by being able to compromise one system, I was able to access this admin file. So this teaches us, I think, 2 lessons. How am I doing for time, by the way? I kind of didn't quite track given the... OK. So this teaches us 2 lessons. Any guesses? What security mistakes happened here that we can point to? Yeah, one and maybe most obvious is, my secret is in the code. It's worth noting that this is bad. This is maybe worst. Like this is literally checked into my GitHub repository and communicated up, potentially compromising my wife's Amazon account. But even if it was a little bit more subtle, even if it was encrypted in the code, even if it was in an environment variable that was populated on boot time, all of that information was within my reach once I got that internal credential. So that's problem number one. I exposed secret. How should I have handled this? Do you know? In the world of AWS, you use a KMS. In fact, in any one of these worlds, you use a key management server. They're very easy. You're already there. You're already in the function as a service environment. Put those secrets away. Don't put them on the machines. Those systems are much, much more secure. The second problem that happens here is that I had these admin functions on the same place. And the reason I did that is because I'm lazy. I'm generally lazy, but I'm specifically lazy like most developers. And instead of having two separate serverless YAML files or serverless deployments and configuring their policies and their networks independently, maybe accessing the same database, I just threw the whole lump into one file. Now this happens in the vast majority of cases. It's convenient. It's one file. I just put a bunch of things here and it deploys them. And there's never ever a path between one to the other. But in practice, there's no reason why my render function would have access, would have the code for the admin UI on its system. But if you were to zip up and deploy these as one application and just different function entry points, that's exactly what you've done. You've sort of increased the attack surface. There's more code on it that it can potentially be invoked. There are more secrets on it that may potentially be leaked. It's just exposed attack surface that it was unnecessary because we bundled and we coupled the two together. So let's continue abusing this admin a little bit more. Let's look at how it's built. So this admin function that we have has an admin API, which if we looked at the code of it, has the secret in it, as we've just seen. But basically what it does is it goes off and it checks, it comes in and it says whether you got the query string with a secret. Also, by the way, not the best way to pass a secret, but roll with me. And check to see if that is indeed matching the admin secret that I have in here. And if it doesn't, it fails, right? If I went in here a little bit, do I have an example of this? Yeah, I might not have an example for it, but if I was to sort of send a request to it and it didn't have the right token, I would fail. If it succeeds, then it goes on to take the verb that I just asked, if I ask for restore or serverless or a backup, and it invokes the relevant function. Now I did this for simplicity. Typically you wouldn't necessarily say lambda.invoke, you would put it into some queue and you would run it, different methodologies to do it, but logically it invokes this other function, that backup or restore. On the flip side, the functions themselves, backup and restore, are internal ones. They're not exposed externally. There's no API gateway for them. You can't directly call them. And because of that, those functions themselves do nothing. Now, they, at this point, do nothing literally. They don't even backup or restore. But what I mean to say is that they don't actually apply any security tests. They rely on the fact that the admin API is keeping them safe and that they are not exposed to the internet. Now, we have remote command execution on this service. So what can we do? We can call the function directly, precisely. So let's do that. Why not? We're over here. So we can, this is, at the end of the day, just a piece of code, right? So this piece of code is a little bit more elaborate than the previous ones. It goes on to do lambda.invoke of the, It goes on to do lambda.invoke of the sort of function that I have in here. And it's worth noting that while it might seem like I have a lot of sort of backscene knowledge and understanding of this application, these things are very easily enumerable, right? I'm just saving ourselves the time here. You do this discovery, you can do a network scan to find out what's around, you can do it casually so you don't get caught. That's assuming anybody had a security monitoring system that worked on serverless applications. I don't think such a thing exists. Basically I'm just sort of sparing us these stages, but there's no voodoo around finding out which function names are around you. So if I do this, I will just invoke this function and I will call the restore function because that's much more damaging in potential. At this point, I didn't really bother trying to get the results of it, so we're just gonna come in here to the function again, and I just created the log for it. I will go to, where is this? Internal restore, go back here, find my timestamp here, it's 1:30, it's behind, and I can see that performing restore was called. Whoop. So again, I didn't quite sort of bother doing it. So to an extent, this is the same offshoot of the problem that we did before, which is we bundled all of this application together. But this manifests a potentially bigger problem, which is permissions. So at the top of this funnel that I have some actions that are allowed. For instance, because of this admin API, I allow the invocation of a function between one function and the other, because that's how I work. And that suddenly gives my render function the right to invoke another function, which really it shouldn't have. And then to top that, it protected, exposed, or sort of made even worse, the fact that this render function sits in the same network and is in a different sort of scope to the admin function, which it shouldn't be in the first place, right? So the damage I did with the admin, bundling the admin and the sort of the to-do handling is threefold. 1, access to code. 2, access to policies. 3, expansion of policies. How could I have handled it? Could have had a separate policy file, could have deployed those separately. The second learning that comes from it is around the notion of a perimeter in the world of function as a service. So in this case, I have this function, internal backup, internal restore. And you know, I mean, you deploy this function right now, and you know that this function is only called from the API. But this knowledge is short-lived. First of all, systems change. That's a whole notion of functions as a service. Each of these functions is its own thing. It's its own entity. If the functions secured themselves again, if each function considered itself an entire perimeter and put the security controls on it, we wouldn't have this problem. There would have been additional lines of defense in here that would have prevented this expansion. So you might get exposed because somebody hacked into one of the functions and got into the other, but you also might get exposed by your peer developer, or even yourself a year from now, introducing another function, calling this restore function, wrongfully assuming that it would have those security controls inside. Security controls and authentication sound a little bit more common to highlight, but what often happens as well is or security controls that are often omitted are things like input sanitization or output sanitization, where you say, well, this function is called in the middle of a chain, so I can already trust its input. Don't trust these inputs. Don't assume that a function is protected by another function to the degree you can. So this was like a bit of a journey hacking this application. Let me see if I forgot anything. The last thing I want to show you in kind of this demo before I summarize is this function here. Simple HTTP endpoint of a vulnerable function. And the reason I want to show it to you is that I have no idea which function this is. I really don't. It just happened to be there. I might have experimented at some point, and I deployed it up there. I'm not even sure, like the name kind of tells me a little bit what it does. I don't use it. I definitely don't invoke it. But it's there. I mean, it's there because it doesn't cost me anything, right? It's just running there. If I don't use it, I don't pay for it. There's some like negligible storage costs for it. And this is a theme in the world of serverless, right? There is zero cost to sort of operating unused functions, and there's zero barrier to deploying a function. It's all so easy. And you think of it that there's no cost of ownership. There's no kind of long-term problem with just deploying everything. And there's a lot of these stories around people deploying, hey, I had this cron job and I moved it to be a Lambda function, right? Or something of that nature, or just experimentation. Now that's awesome, right? It's awesome from a productivity perspective, but it's also false from a security perspective. Over time, one of my biggest concerns about the serverless ecosystem is just this explosion of attack surface. You're gonna have 1,000 functions, 10,000 functions in there, and once something gets added, it's really hard to retract it. You don't know whether it is important and it's just some disaster recovery function. Nobody's using it because it's waiting for that. You don't know if somebody cares. So today, there are no good tools to sort of track that type of ownership. So really, it's on you to know why are these functions there? Segregate the networks, deploy them into different networks so you know the important stuff is here, and these ones are disposable, and you can chuck them. Because each one of these, like in this case, not even digging into which ones, what are the vulnerabilities, this is a function, it has 4 vulnerabilities, and an attacker can use that either as a launch point into potential private networks in your system, or at the very least, to sort of serve malware or send spam email from your systems. So there's definitely a concern here, and that concern will grow and grow as you use serverless more. So with that, let me just sort of summarize the points that we talked about. So this was a little bit for fun, right? It's not a checklist for you to do, and it's hopefully it sort of demonstrates a little bit how with very simple and common mistakes you can expose some pretty severe damage. There was no like independent thing that was super wrong in anything that I've done, but it accumulated to a complete compromise of it, and I didn't even get to trying to dig into the database because I ran out of time. So you can do some it's easy to make horrific mistakes. So just to quickly enumerate them, beware of vulnerable libraries, use some tool to be able to know whether you're using vulnerable dependencies. Those are the easiest way for the attacker to test you and will be included in the statistical. You don't need to be targeted to be attacked via known vulnerabilities in libraries. So I'll kind of skip this example. Just to point out, this is another example. Their dependencies and libraries are the majority of your code, and therefore they are also the majority of your vulnerabilities. So just worry about that. RDoS, all in all, you're in better shape than you were before because of your availability concerns, but it can be literally costly. So still be wary of it. Think about compute time. It will save you dollars at the end of the month. Avoid secrets in deployed code. In all deployed code, use the KMS. Don't rely on immutability. These services may get computed. Many of these are defense in-depth concepts. You still need another vulnerability or risk to be able to get there, but they're important ones. Use granular policies. Don't fall for the convenience of just like, sure, I'll just lump these in. Policies expand, they don't contract. Once you add a policy, a permission to a policy, nobody ever feels comfortable removing it. Policies expand, expand, expand until somebody adds an asterisk. That's the way it works. And similarly, deploy granular functions. It's not much harder once it's the norm in your system to have separate deployables for each one of these functions. And then last but not least, worry about all functions. Don't just think about the one, especially when you think about your system and your company as a whole. There is that talk, there are other conceptuals, again, to remind you. You can go off and talk about a little bit more the theory behind this. In this other talk that I have, this was kind of the summary slide, but it's hard to understand it independently. And then kind of to leave you with one kind of positive sentiment, one of the things that are great in serverless is that is sort of the pace of the community and the fact that it's, we're sort of helping now shape the best practices in it. So we have the opportunity to build both into the tooling and into the practices and into the culture that we have here, the notion of security as an aspect of quality, and to build the best practices that would make this ecosystem more and more secure over time. It's kind of an opportunity for us to build that now. So let's do that. Thank you.